Good morning, students. So today we are going to start chapter 4, Physics, Simple Machine. So before discussing about simple machines, let's know what is work. In our day-to-day life, we refer to doing work like reading a book or solving sums. But in terms of physics, work is said to be done if a force acting on the body moves it or changes its position or shape in the direction of force acting on a body. Suppose two boys are moving a heavy box. Okay, so the force is applied. Okay, and if the body moves to a certain distance, then work is said to be done. If the boys are not able to move the box, then what will happen? Force will be applied, but there is no displacement, so the displacement will be 0, so work done will be 0. Okay, so work done in physics is equals to force multiplied with the displacement of the object. Okay, so that will be force multiplied with the d. So in terms of physics, work done is force multiplied with the distance of the object moved. Okay, so if distance will be 0, then work done will be 0. That's why when you are sitting and reading the book or sitting at a place, then there will be no work done. Okay. Now, energy is the ability of a body to do work. Okay. So, these two terms should be clear before dealing with the simple machines. Now, for doing our work in day-to-day life, we use many different machines, okay, or different tools like a scissor or a knife, okay. A tape dispenser, if you will see, it also has a small blade around it. So all this, the small blade or the scissor, knife, all these are simple machines. So before going to that, let's know what a machine is. So a machine is a device that allows a small force or the effort to overcome a larger one, that is load. Okay, so the bottle opener, the use simple machines to do work in our daily life. Okay, so machines are used to lift, move heavy objects and also reduce the amount of effort. Like if you try to open a bottle cap with the a bottle opener, it will be very easy to open. Okay, so similarly the scissor is very handy to cut off the piece of paper. So with a very small effort, we are able to cut the piece of paper or cloth using a scissor. Okay, so the simple machines, what they do, they are used to lift objects, okay, or move objects, and the amount of force applied is very less. So with very less effort, we can move heavy objects. Okay. Machines are of two types, a simple machine and a complex machine. So, simple machines are basic mechanical devices that we use in our daily life, like scissor. But if you see a bicycle is also a machine. So, it has a lever, okay, and it is made up of a series of different simple machines. A wheel is also attached, so wheel and axle attachment is also there. So different types of simple machines are joined. Okay, here are the different kinds of simple machine: a crowbar, screw, okay, wheel and axle, knife, tongs, pulley, inclined plane, etc. So here the bicycle, the sewing machine, scooter, tractor, these are the examples of the complex machines. So here a large number of simple machines are interconnected, and that's why these kind of machines are called as complex machine. The principle of a machine. On what principle the machine works? So machine doesn't work by itself. If you will keep the scissor like this, it won't work by itself. We have to apply some force to make it work. Okay, so a force was applied on a machine, and then what happened? The machine works. The applied force, the force which we apply on a machine is called an effort, and the force exerted by the machine due to this applied force is called load. Okay, so the difference between the effort and load is what? The effort is the force exerted by the machine, and to this applied force is called effort. Term is the fixed point. So this is another term about which the machine can turn and while doing any work, that is fulcrum. Okay, then there is input energy, the energy supplied to the machine, okay, or the work done on the machine is called input energy, or simply it can be called as input, and the usual work done by the machine is called output. Okay, now let's see the efficiency of a machine. Efficiency of a machine can be calculated by the work done by the machine on a load, or divided by the work done on the machine by effort. Okay, so you can say it is the ratio of the useful work done by a machine to the work done on the machine. Okay, so it is usually expressed in percentage. Okay, so that will be output energy by input energy. Okay, so you can write the efficiency as, okay, or output energy by input energy into 100. Okay, so in case of an ideal machine, the efficiency is 100%. Okay, now let's see the mechanical advantages, and then we'll see the types of the simple machine and ideal machine. A heavy rock can be easily moved using a crowbar. Okay, so what happens? The force is applied and the simple machine multiplies this force, and with the less effort we can easily move this stone out. Okay, then in a convenient direction also we can apply the force. Okay, so if you will try to directly lift this rock, so it will be back breaking, no? Then what happens? So if we will use a simple machine just to lift heavy loads, like when we are pulling the water out from the well, then the force is applied to a convenient direction and it becomes easier to lift the water from the well. And see, by permitting to apply force in a convenient point, like when we fix a screw, the force is applied at the handle of the screwdriver, but it acts on the head of the screw. So this permits a force at a convenient direction. What is an ideal machine? So an ideal machine is a machine in which no part of the work done on the machine is wasted. That means its efficiency will be 100%. So that work output will be equal to work input. Okay, so what happens? This kind of machine in general doesn't exist. So in actual life or actual machines, the work done on a machine is lost. How it is lost? In the previous chapters we have learned about friction. So in overcoming that friction of the moving parts between the machines, so the work done is lost. So work output will be lesser than the work input, and the efficiency will be lesser than 1 or less than 100%. Now let's see the mechanical advantages of a machine. So the ratio of the load lifted by the machine to the effort applied on it is defined as mechanical advantage. Okay, so mechanical advantage, the formula is load by effort. So it can be greater than 1, equal to 1 or less than 1. You can also define it as the factor by which a machine multiplies the force applied or the effort of the machine is called the mechanical advantage of machine. So the factor by which the machine multiplies the effort is called the mechanical advantage. So it is a pure number and it has no unit, and it can have the value greater than 1, equal to 1 or less than 1. So if the mechanical advantage of a machine is greater than 1, then what it will mean? It will mean that the machine is a force multiplier. Okay, so that is a good machine. Now let's see the different types of simple machines. So there are 6 different types of simple machines. The lever, screw, pulley, inclined plane, wedge, and wheel and axle. Okay, so we'll start with the lever first.